everyone. I am Michał. I'm a machine learning engineer at Pstrąg AI, and today I'm going to talk about programming foundation models with DSPy. And the talk is based on my recent experience with this tool. We managed to use DSPy in our open source project called DBAlly, and we found it quite useful for our use case. We had some prompts to optimize, so we leveraged the DSPy to do it for us. So I will try to share some insights that we gained while working with this library. And also, before we jump in, like quick side note, all the recommendations, pros and cons that will be given in this talk are given for now. The branch is developing rapidly, and things might be different in a few weeks or months. So just keep that in mind. And yes. So we are going to start with some context. I will briefly describe how you can improve language models performance in your pipeline. We will discuss different ways to achieve this, and we will discuss different prompt engineering methods that you can use to do this. Then I will introduce to you DSPy and briefly describe some concepts behind this library. Then we will use DSPy for a multi-hop question answering problem, and you will see how you can leverage this library to model this task. And then I will briefly talk about some alternatives that you may consider when trying to optimize your prompts that are quite a little bit different than DSPy, but they are based on a similar principle. And at the end, we will summarize what we've learned. So first, maybe let's try to answer the question, why is it really important? So why do we need to like improve? What are the ways to improve LM performance? So there are like 3 ways to do it. And first one, the most fundamental one, is to come up with a better model architecture. And it's given the last decade, we can like say that it's highly unlikely that we will have anything better than transformer, and it's really hard and costly to develop a new architecture and research it. So this is the promise that we may have to, if we will have better architecture, we can dramatically improve on performance, but it's really hard to achieve given the history. Then we can try to scale training data, which is what most big companies do, or companies with big funding like OpenAI or Meta. They kind of try to scale compute and training data to achieve better performance, but the underlying model stays pretty much the same. So they kind of want to leverage like this part of performance. And then we have better prompts, so we can kind of try to write better inputs for these language models that are already trained and improve performance from this side. And this is the most popular way to boost the performance because it's the cheapest one and it's the most accessible thing like you can't do. So when it comes to better prompts, you can do it in 2 ways. You can do it manually or automatically. And the manual way is like the most common one because it's the most intuitive way to write prompts. So you just write a large string and you test it on a language model. How does it perform? And then you try to iterate on this like huge string that you produced. But on the other hand, you can do it automatically and leverage some library like DSPy, for example, to bootstrap prompt for you, and then use some sort of optimization algorithm that would try to make this prompt better in an automated way. So you won't need to write the prompt, like the whole prompt yourself. And when it comes to manual prompt engineering, you have like a full control of the development process because you know exactly how the prompt is going to look like. There is a short feedback loop, quick iterations. You know exactly what do you want to change because you wrote the whole prompt yourself. There is a potential for high quality results, If you have like right domain knowledge, you can model the language model in a way to serve you, but it's not guaranteed. When it comes to cons, it's time consuming, especially if you have like multiple prompts to maintain. It doesn't scale well if you have multiple prompts and they are like really complex one. That's the thing you need to keep in mind. And it also requires you to have certain expertise in tasks that you are modeling. So if you lack this expertise, if you lack this domain knowledge, you might not be able to come up with a prompt that would actually score good results. When it comes to automated prompt engineering, it saves you time, but minimizing the manual prompt crafting. Most of the time, it's just a single line of code that you write, and you will have something that works. So you can start very quickly. They're fairly easy to scale. You can very easily bootstrap multiple prompts and chain them together and see how they interact with each other. And most of the tools gives you tool chains to like easily adapt this prompts for different models and tasks. So you don't really have to think like how I should change the prompt when I switch the model from GPT to Claude, for example. When it comes to costs, most of these tools for automated prompt engineering, the main feature is optimization algorithms, and they require some amount of data. Most of them, if you want like to have really good performance, require a large amount of data, like thousands of examples that would allow them to optimize your prompt. There are also risks of overfitting to a specific task. If you have poor data, you might come up with a too specific prompt for the task, and it might perform poorly on more generic use case edge cases. And they're also costly when it comes to long pipelines. And like you want to do like really deep search, optimization search, it will result in many LLM calls. And if you have multiple prompts, it might get quite costly. So this is something that you need to keep in mind, that it's not for free. And yeah, and speaking of automated prompt engineering, there is a tool called DSPy, which is a framework for optimizing LM prompts and weights. And it was developed at Stanford University and originally published in a paper called Demonstrated Search Predict in Python in December 2022. And it's been open source since January 2023. So you can easily check the code and play with it. And what DSPy really did, it introduced a new paradigm when it comes to prompt engineering. And they said something like, let's program, not prompt language models. So you kind of want to shift your thinking of language models and think of them as some sort of machines, devices that you can program. So there's like a easy comparison to computers, and you kind of want to look at like these models this way. And DSPy introduced three main concepts. There are signatures, which allow you to bootstrap quickly a prompt. They allow you to say like what is the input and what is the output of the prompt. You have modules, which are like thin wrappers, like abstraction around certain prompting tricks and techniques. And they're general purpose. You can chain them together. And you have optimizers, which are used to generate refined instructions based on the signatures and modules. And when it comes to signatures, signatures are like declarative specs that tells the DSPy what the transformation does, rather than how to prompt the LM to do it. And there are two types of signatures. This is official classification. You have inline signatures, which are simple one-liners, string, Python string that declaring inputs and outputs. And they're really simple. Like you will get a really similar prompt format for every signature. So the only thing that will change is just the name of the inputs and outputs. The instruction is pretty much the same. You will see in a minute how does it look like. And you have verbal signatures, which are kind of more complex. And these are Python classes. And you can declare inputs, outputs, but also a task. So you don't rely on this like bootstrapping of DSPy. You can write a description of your task yourself. And the prompt format depends on the implementation. So each verbal signature will be a bit different depending how you structured it. So inline signatures are pretty simple. You have a one-liners Python string, and it gets like converted to bootstrap prompt that just lists your inputs and outputs, and that's it. It's pretty simple, but it's like a good start when you are starting to writing your own prompt. When it comes to verbal signatures, you need to declare a Python class. And in the doc string, you specify the task you're modeling. And then as attributes, you specify inputs and outputs with the specific objects. And you can associate with it some metadata. So the prompt can, like, you can really like structure the prompt yourself, but you will still fall into some sort of formatting that, like, first line is always that what do you want to achieve, and then you have the bottom section, which is like how the input and outputs are formatted. You can also type these attributes to get even better performance for some tasks. But yeah, this is like just syntactic sugar. All right, so the second concept that I mentioned were modules. And module is like parameterized layer that expresses the signature. And this is like abstraction around prompting technique. Most of them are abstraction around prompt technique. And once it's declared, it behaves like a callable function. And there are two types of modules. And this is not official classification. This is how I look at these modules. So you have something I call signature modules, which are like literally like wrappers around signatures, and they allow you to use certain prompt technique within a single line of code. And these are like already implemented in DSPy, like chain of thought or React agent. There are many more, but these are like the most popular ones. And they modify underlying signature. You will see in a minute how does it look like. And then you have a composite modules, which are kind of similar to layers in neural network modeled in PyTorch. And they are like containers that aggregate multiple other module chains together. So most of the time you will have like multiple signature modules inside and maybe some tool calls. You'll also see how it looks like. And yeah, as I mentioned, they include different calls for language models and tools, for example, retrieval for RAG application. So signature modules look like this. You have again, single line of code. You just call this by chain of thought. You specify the signature. This is the verbal signature that you saw earlier. And as you can see, like DSPy injected reasoning field into the signature, and we have a chain of thought essentially. You can have a React agent built with this signature, and as you can see, it got quite complex. So that the whole formatting got changed. And yeah, just with a single line of code, you have like bootstrapped the whole React agent, which is really cool. When it comes to composite modules, as you can see, that the syntax is really similar to PyTorch. So first, you define modules you want to use in your program. So in our case, it's just a simple RAG. So we have a retrieval and chain of thought module, which is a wrapper around our generate answer signature that you saw earlier. And in the computation part, which is the forward method, we specify that the order of these modules to be executed. So first we want to retrieve some passages and then pass the context into generate answer prompt and get a hopefully meaningful answer. Yeah, and the third concept that I mentioned were optimizers. And when it comes to optimizers, this is like, I think, the most important part when it comes to DSPy, because this is like the reason why we want to really use this tool, is our optimizers, and they are used to improve your bootstrap prompt. And there are 4 types of these. They work on different parts of your prompt. So for example, you have automatic few shot learning optimizers, which kind of try to find best few shots for your task. And they are injecting these few shots into the bootstrap prompt you created earlier. And they can like randomly pick a few shot from your training data set, or they can use language model to bootstrap few shot based on inputs and outputs of your module. You have automatic instruction optimization optimizers, which work on instruction level. So you are not really focusing on few shots, but you also want to change the instruction. So you wrote some instruction in the doc string, and then you want to improve it using language model. So you have optimizer for this. It's called Copra, but there are also other types of optimizers that do this in DSPy. You can also fine-tune your model. So if you have something called automatic fine-tuning, and you have an optimizer that will track your modules, and for each module, it will generate weight updates for a language model. So you'll be able to find a really small model just for single module that you have in your pipeline, and you will have multiple of these. So this is really interesting, but it's kind of low-level thing, and most of the time you won't start with this optimizer, but it's when you want the really good performance. And you also have something called program transformations. So there is one optimizer for now called Ensemble, and it allows you to get like multiple modules and try to reduce them to single module or 2 modules, which is also very interesting. But yeah, it's just a different type of optimization you can do. But the most popular one are just automatic instruction optimization and few shot learning. Okay, so maybe let's try to model something in DSPy and let it be a multi-hop question answering. This is like a really common example. You can find it on official documentation. And we'll do this on a hotspot QA data set. And how this data set looks like, you have a single example here. So you have a question. And what's interesting about this sort of questions is you cannot answer them directly. You need to like fetch some context. And this context is like twofold. So you need to kind of ask different questions before you answer the one that was asked by the user. So in this case, we are asking who was born first, Tony Kane or Deepa Mehta, and we need to fetch 2 passages about Deepa Mehta and Tony Kane. And based on these passages and the data inside this document, we want to generate answer. In this case, is Deepa Mehta. She is 2 years older than Tony, by the way. Okay, so we are going to build a pipeline. And in order to build a pipeline, we need to create a composite module. So our composite module is going to be built with 2 prompts, 2 chain of thought prompts, one for generating a query for the retriever, a tool call to retrieve the passages, and then final prompt for generating answer based on fetched context. And we are just using like simple inline signatures and chain of thought module. So this is going to be hard-coded to hop question answering. And yes, so uncompiled program without any optimization looks like this. So nothing new, like simple prompts bootstrapped by DSPy. The only difference is just the output part. In the first prompt, we want the query. In the second prompt, we want the answer. And when we run the evaluation on this pipeline using exact metric, we will get 18% of performance, which is really, really bad, I think. But this is what we expect, because it's just like a simple thing with Bootstrap, just few lines of code. So we don't expect any fancy things. But what if we will try to compile this program? So first we need to define a metric that we based on which we want to optimize this program. And in this case, we are looking for exact match for for answers, passages, and we also doing some computation when it comes to how a question is similar to the queries being generated by the pipeline. And for the first compilation, we are going to use Copro Optimizer, which will optimize only instructions for our pipeline. So you call it with just 2 lines of code. And the compiled program will change these 2 modules, the first one and the second one. So as you can see, when we run this compilation, we will get like longer, more sophisticated instruction, what LLM should do. And as you can see, it scores a little bit better. We managed to improve the performance with just 2 lines of code and some data. But we can also try to optimize it further and maybe change the optimizer. Let's try with the Bootstrap few shot. The rest of the code remains unchanged. And the compiled program is a bit different now because we didn't change the first prompt. The first prompt stayed the same. The compiler won't generate few shots for this module, but for generate answer, it will generate for you by default 16 few shots picked from either from a data set or Bootstrap using language model. So you will get it like this prompt and this pipeline, this optimized pipeline using Bootstrap few shot will achieve 50% of performance, which is quite good given our first score. So yeah, so this is the way you can sort of, experiment with different optimizers, try really simple, and then iterate to get better performance. So how to get started? I highly encourage you to check the documentation. Most of things are well documented, not that like the whole API is well documented, but most of the optimizers are documented, so you can, without like checking the code, you can read about them, how they work. There are some schemas and things like that. You can also check notebooks. There are lots of official examples. There are also community examples, like tree of thoughts for creating persuasive arguments in the debate, or one user on X shared state-of-the-art reaction extractor based on Biodex dataset, which is reportedly a really hard problem to address, and it's really hard to write a prompt manually for this. So he managed to hit SOTA with the DSPy, which is quite interesting. Okay, and you might think about alternatives, because DSPy is kind of like major tool. There are some new tools that were introduced like recently, like Adaflow or TextWrite. They all are based on the same principle that you want to optimize your prompts in an automated way. So they have like their own optimizers, and they kind of treat the prompts differently, but the base principle stays the same. You can also try OpenPrompt and LMQL for better prompt structuring if you want to just experiment and like format your prompts in a different way. Yeah, definitely give them a shot. And to summarize, I think DSPy is a good choice, especially for early phase of LM pipeline development. If you have a major product and you have lots of prompts, I don't think it's worth to rewrite everything to DSPy. You won't get much value out of it. But if you are just starting a new project and you feel comfortable with the API, I will definitely encourage you to start with DSPy. There is a bit of learning curve. DSPy isn't easy. It's not an easy concept. You should like to develop some feeling and to better understand the tool before you will apply it in a client project. And always start with the simple signatures and then iterate. So most of the time you want to start with a simple one-liner inline signature, and then you might try to write a Python class for this. Same applies to optimizers. Start with CoPro, then you maybe want to try to find some few shots or something like this. Like fine-tuning LLM should be the last thing you probably need to do. DSPy isn't a cure-all. Some tasks can be difficult to model, even for automated tools. So just don't take it for granted. DSPy might not solve your problem. And DSPy scales well with large data sets for evaluation and refinement. If you don't have enough data, I mean, if you don't have like, you know, depend on the problem, but if you don't have data set, you probably won't get much from DSPy. So this is really important to have some data to run evaluation and be able to utilize optimizers. And what's the most important thing is to not use it in production. It's just like, for me, it's a purely research library. So you shouldn't put it in your production requirements. It should work like you have a research environment when you try different prompt techniques, different pipelines. And then once you feel comfortable with the performance, you're satisfied with the performance, you just copy paste the prompts that were generated by DSPy, and you are pasting them into your production environment, and this way you are using DSPy. Okay, so this is what I have prepared for you. Thank you, and see you next time.